Okay, so this is an example of how to use the ideal gas equation. The question is from a past paper by AQA in 2006. So the first thing you have to do is read it and underline the key information using a highlighter or a pen. Here it says the volume was 1 times 10 to the minus 3. The decomposition produced a total of 0.873 moles at a temperature of 1100 kelvins. So the whole point of this question is to use it to calculate the pressure. So we are finding out the pressure. Here, going back to our gas equation, the second thing we have to do is rearrange the equation to get P on the left on its own. Now, how you do that is divide both sides by V. Here, if we just divide both sides by V, we get P equals N R T over V. Now, the third thing we should do is check that the units are correct, or convert them if they're not. So the volume should be in meters cubed, and here it's in meters cubed, so we don't have to convert it. And the temperature must be in kelvins. Here the temperature given to us is already in kelvins, so we don't have to do anything. Just plug in the numbers into the formula. Plugging in the numbers, we should write 0.873 times by the gas constant 8.31, excuse the messy writing, times by the temperature 1100, all over volume, which is 1 times 10 to the minus 3. Now when you type all of this into your calculator, I suggest you use the fraction method which you have on the calculator, on a scientific calculator, because it makes it easier and it makes sure that you get the right answer. So writing this into the calculator, 0.873 times by 8.31 times by 1100 all over 1 times 10 to the power of minus 3. The answer you should get is 7980093, and the units pascals. So that should be your final answer. If you didn't get that the first time, you should go back and check and see if you can find where you went wrong.